Okay, so let's look at this ISO framework more in detail. We just kind of started it towards the end of the last module. So we'll continue this discussion on ISO framework in this particular module. So again, I have put that slide again for you to recap. So we had ISO framework, we have goal and scope. We were discussing this goal and scope. Life cycle inventory, life cycle impact assessment, and interpretation. We'll go each one of those. And I said it's an iterative method. That's why you have the arrow on the both sides. So where if based on how you learn here, things may change along this line too. So we looked at this slide already in terms of you should have a goal means what and what it is for. That's goal must clearly define the object of this and as well as the reason and the intended application of this study. So goal must clearly define the intended audience of this study as well. So and the other part of the goal is for who we are doing this study. Who is our intended audience? So again, as I said earlier, the bottom part of these slides, the top part is kind of my summary to help you kind of learn it, and the bottom part of these slides are, especially the ones with the smaller font, are just the copy and paste from that ISO document. It's just for you to help you out. So the examples of link between audience and application, again this came from the ISO document. You can have from a consumer. So if you want to from the differentiate functionally equivalent product to make more ecological choices. So this is what exactly I was telling you towards the end of the last module regarding two similar cell phone, two similar mobile, which has similar price, similar kind of RAM and memory, and these days now you need to have two cameras. One is the front camera, back camera. Many times I don't understand why you need those kind of stuff, but you have to take a selfie, which is the whole country is kind of crazy about selfies sometimes. But these are the products. So we have to live with the product. We cannot. So these are, if it's a differentiate functionally equivalent product, as if English suggests, functionally they are equivalent. So they can perform the same function, but coming from two different brands. So now if one brand is better ecological, so doing this LCA exercise, if you want to do the marketing, your goal is to convince the consumer that my product is ecologically better. So you go and buy this product. So so the audience here is your consumer. Now if the audience is the manufacturer, so here you want to reduce the impact associated with its product and to communicate their environmental merits. So that's where the government policies also comes in picture too, where the manufacturer, like for example, recently we did a project for, project was at Nalco Angul plant. Some of you may be familiar with, it's in Bhubaneswar it is in Odisha near Bhubaneswar. So in Angul plant, what they have is they have a cogeneration power plant. As part of the cogeneration power plant, CO2 is released. So this carbon dioxide that is released, they are taking this carbon dioxide and feeding it to microalgae. From that microalgae, after they kind of grow microalgae, harvest it, and they are making biodiesel. So this biodiesel is used on site itself. So it's a small kind of a demo pilot kind of project, which Nalco is doing, in some of the other agencies are also involved, so they are doing it together. So they want to actually demonstrate, so they want to in this way they are reducing the associate, because what they're doing, the CO2, rather than getting into the atmosphere, they are capturing the CO2 and producing biodiesel, and then the CO2, this is like a carbon sequestration project. So it helps show them a better environmental footprint. So that's it shows them in a nice environmental footprint with that. So that's what the manufacturers can communicate their environmental merits by doing that. So that's one way of doing it. Same thing for any product, they can do it. For the government, government can take this LCA study and refine the environmental legislation. They can come up with and also elaborate incentive measures. So they can come up with incentives to people, to the companies, to the manufacturers who are more environmental friendly. So to make things more environmental friendly, and some of these international organizations and some of these governmental organizations in the Western European and other countries are already doing it. In India, we are a little bit behind. Just last year, at that time, our the environmental minister, who is now our HRD minister, he did mention in one of in one of the gatherings that in India also we have to start looking at LCA more seriously. So that's hopefully the things will grow. So that's the reason why I'm offering this course. So in Indian context, LCA is still I would say we kind of just started doing LCA in India. There are some studies already done, and there are some papers already published, but things are again just started if you compare with the Western European countries, but things will pick up. So if you get to know this concept, if you can understand how the LCA is done, since it's a newer topic, not many people are aware of it, and not many places this course is also offered. So I think this would be one of the first course offered in this topic in the country, especially on the online mode. So it gives you an opportunity to learn this course and then learn something which you can help you market yourself. Although it doesn't sound very nice to market yourself, but unfortunately we are in an era where I should not say unfortunately, this is how the things work these days. You have to really show that, say if I'm a company and I want to hire a person, and you should have that skill set which will help me run my company better, which can help me run the things which I need to do. And most of the companies these days have to have their sustainability reports. Sustainability reports so far has been just kind of making a very nice, beautiful report without much technical meat there. But the government is also getting very careful. The government is being pushed by international funding agencies as well, that you need to look at these environmental footprint things in more carefully. We have so many international laws are coming up. So saying from that perspective, somebody who is familiar with this LCA exercise, who knows how to do an LCA, will have a better chance of getting a job as opposed to somebody else. So that's the reason. If you don't see any other reason to take this course, at least that is a very valid reason for you to take this course and earn credit. You should not only take this course, do all the assignments, and also take the exam, which we will offer towards the end of the course. So take the exam so that you can get a certificate that you have successfully completed this course, and also tell your friends about it. So in terms of the goal must be the intended audience, the consumer, the government. Based on who is our audience, we can tailor our LCA study accordingly. So for the goal will, what the goal does. So this is a kind of goal will guide us in terms of the depth and the scope of this study. So based on the goal that we have, we will to say, okay, what should be the system boundary? What should be the system we want to study for? What will be the functional unit and the reference flow? Remember that function and functional unit, we kind of already showed some examples. So what kind of functional unit, what will be the reference flow? The functional unit for those light bulb was to provide the light. We didn't worry about the secondary function, just the primary function we took over there. Then reference flow, we took 10 bulbs and 1 bulbs. So that's what we are talking about. What should be the reference flow to meet the functional unit requirement? Now the system boundary, most of the time it will be cradle to grave, but sometimes it could be cradle to gate as well. So for example, those 2 bulbs, if you think about, if you are a bulb manufacturer, you may say that I don't want to do it for like a use phase and the disposal phase, because I have no control. And that's a very valid argument as well. Say for example, if you are making a product, 2 different types of soaps, for example, it's like a regular soap or cloth washing soap, like your different brands out there, like a Rin, or there are a lot of brands out there in the market. So say if you are making if you are a soap manufacturer, you have sold the soap, you have given the soap to like a multi-retailer like Big Bazaar, or even if a small shop, and then after that you don't really have much control on that product. So when people use it, depending on how the people will use it, it may and also depends on what kind of water is there. It depends what kind of emissions will come out, and what will be the rate of release of those emissions, how long the product will last, and how in the water that comes off, if you are living in a very nice city which has a very good wastewater treatment plant, the impact will be much less, because the soap water that you are releasing while taking bath, that soap water is going to a nice wastewater treatment plant. So it's will have some sort of better kind of control. or if you are in a place where this soap is being used, there is no wastewater treatment plant, the impact is different. So as a soap manufacturers, you may make an argument that I have no control on how this product will be used. So why you are penalizing me in terms of what will happen after I have given it to the consumer? But that's not a cradle to grave study. That's a cradle to gate. We call it a gate because the gate of the plant, that's what we are trying to say. If once it leaves the gate of the plant, as a manufacturer, I don't have control on that. So that's why we kind of stop there. So that's the system boundary, like what should be the system boundary. But usually we try to go for a cradle to grave study because that's the most complete study. Then what should be the unit processes? What the unit processes we need to include? Again, that's what the unit processes for a very detailed, say if you want to have a detailed study, you want to use all the unit processes involved in the manufacturing of any of those product. But these unit processes, you may not have data, but as you will see in subsequent module, that for these unit processes we need to have the data for these unit processes. If we don't have the data, many times what we do is we club some of these unit processes together for which we have the input data and the output data. So, and then allocation rules, we did touch upon this allocation part a little bit earlier. Allocation is when you are trying to allocate both in terms of the primary function and the secondary function. You can allocate say 60% for the primary, 40% to the secondary, and you will see that a little later as well. But that's the allocation rule. Same thing, you can do the allocation when you are looking at the midpoint indicator to the endpoint indicator, because remember we had a list of midpoint indicators. Now for two midpoint indicators may lead to the same endpoint. So if one particular midpoint indicator is leading to this impact as well as the one impact down there. So when you are trying to take the impact on two different scale, how to divide their ratio? Well, should we take it like a 60-40, 70-30? So midpoint indicator point A doing to the endpoint indicator say B and C. So A have a 60% impact on B and A has 40% impact on C, or what should be that? Whether it's a 60-40, 70-30, 80-20, that kind of we need to have that. For that to make that kind of judgment, we need to have some sort of basis for it, and based on what kind of data like basis we have, we go for say different allocation rules. For all of these, there are some already guidelines out there, so you don't feel that there is all these things are being like a shooting in the dark. That's not. There are guidelines out there which we use and which you will see as well when you start doing some of these LCA exercise. Then data quality. Data quality is very important. We kind of talked about that several times so far in this particular course. So inventory data quality requirement, we need to have a good data. Then life cycle impact assessment method, that impact assessment, how we'll do the impact assessment. Again, we have a different methodology out there. We can use one of those, the ones which suits our goal, like in terms of our scope, we can use that particular thing. And for all these, at the end of the day, we need to have a critical review. So it's not a one-time thing and then you do it and then you just don't. You need to critically review to see whether you are making a good judgment. If not, then you refine it and go for better stuff. So that's your goal. So all of these, as you can probably, if you have listened to the video, the audio carefully, there are some subjectivity involved as well. It's not always objective. Things will be subjective, and that kind of leads to little bit of different kind of interpretation from person to person. There will be some little bit of biasness coming into the system, because how will you do the allocation rule? How will you do the inventory data? What say data quality? The data quality which I say good, you may not say it good, because so. But if we follow those standard protocol, for example, data quality, we have the QA/QC. Allocation rule, there are certain methodology out there. Yes, methodology A versus methodology B, the interpretation may be a little bit different, but of course there will be a little bit of subjectivity involved as you do the exercise, but we have tried to minimize. That's why this ISO methodology has been developed, to minimize those subjectivity and try to have it more objective, as much objective as possible. Then function is the starting point. So in defining, we define the functional unit, which we already did. So that's the reason. Like if you think about, we looked at that those bulb example in great detail. Was one of the reason for me to do that was when I explained to you this ISO methodology, you can now relate to it. Remember that functional unit. The functional unit that we use for those two types of bulb was the calculation reference as well. Remember, we had from that unit process, we took that 1 kg for 1 kg of 1 kg of glass or 1 kg of cardboard, this much different input, this much different output. So that's the, and then for our functional unit, which was 228 grams of glass and 232 grams of cardboard. So that's 228 grams and 232 grams, that's our calculation reference. So if that's the reference we are calculating, that's the base, we are calculating all our input and output. So that's what we are talking about here. That's the functional unit in terms of the calculation reference. Then system boundary is what are the all included unit process. What is all the unit process that is included? That is our system boundary. So it's always not easy to differentiate, identify the function of the system. Some systems may be multifunctional, and if you remember, we did talk about that again. Say if you think about e-reader, regular book versus e-book, remember we talked about that. Most of these e-books, like for example, if you have an Apple iPad or any iPad, Samsung or whichever company you have, excuse me, so that you have this like a way where you can read the book. Say if you have an iPad where you can read the book, you can also do your emails, you can also play games on it, you can check your, you can go on newspaper websites, you can read newspaper, you can watch YouTube videos, you can watch movies, and possibly these you can do a FaceTime, and there are a lot of things you can do with the same iPad. Now it's a multifunctional device. So if it's a multifunctional device, and most of the same thing you can do even on your mobile phone, like this smartphone, you can, most of the things that I said can be done using this mobile phone as well. But if you want to compare this e-reader like an iPad, reading a book on an iPad versus reading a physical book, see, like it's so complex now, because it's a, although it sounds so easy, but it gets so complex, because reading a regular book, of course you are reading a book, it came from a paper and ink, got printed, all those things are there. But when you go for ebook or like an iPad which can be used as a ebook reader as well, now you have to look at, okay, what fraction of the time it is being used as a ebook. Now that will change from person to person. Somebody who is a voracious reader, we probably be using half of the time of reading the book on his iPad. But somebody who read very occasionally will read like a once in a while. So how to take the data? So you need to kind of do a survey to find out, okay, on average, people who has an iPad, who's read also ebook, use at least average 2 to 3 hours per week or per day, whatever the data comes up. Now, based on all the other functions it does, because the energy consumption is not only on ebook reading, so what fraction of energy goes on the ebook reading for in terms of the consumption. You made those iPad, so your iPad is made with different rare earth metals, different plastics, glass, and all sorts of things. Now what fraction of that has to be allocated? So it gets really, the whole thing gets a bit complex. It's not that easy. So that's why the function there is a multifunctional. So you need to differentiate between the primary function and the secondary function. So remember in that bulb example, we ignored that secondary function because I don't want it to make it more complicated. But later on, you will see some examples where we will have to include this secondary function as well, because that's to make it more realistic LCA. So in comparison, the bottom line is that in the comparison, the system must have the same functional performance. Some systems should have the same functional unit. That's the very, very important. That's otherwise you are not doing an apple to apple comparison. So it's your comparison is not fair. So for that, you need to stick with the same functional unit, and then you need to see how if it's a multifunctional stuff, how to take the other functions associated with that and how to do the allocation for this particular function that you are focusing on. So that's how it needs to be done. So once you have this functional function and functional unit identified, then you need to have the reference flow. Reference flow is the amount of product necessary to fulfill the amount of function specified by the functional unit. Now again, going back to that glass like a bulb problem, our functional unit was 700 lumens of light for 10,000 hours. That's what our functional unit. And for that, we needed a reference flow of 10 bulbs of incandescent, 1 bulb of CFL. So that's the reference flow. So that's we have to try to understand that. So reference flow was 10 bulbs of incandescent, 1 bulbs of CFL. If you have not watched that video carefully, go back and watch it again. So but the amount of product that is necessary to fulfill the amount of function is specified by the functional unit. So what must be purchased in order to fulfill the function? So we have to purchase 10 bulbs of incandescent and 1 bulb of CFL to do that function. So that's why it was, so we have to, and it will be different for each compared system. See, it says, remember, even if you think about the China plate versus paper plate, we had that example as well. So China plate versus paper plate, we had, if you remember from the video, we said we will say 30 meals, serving of 30 meals. That was our functional unit. Function was to serve the meal. Functional unit was serving of 30 meals. Now serving of 30 meals, China plate, 1 China plate is good enough unless you break it over a period of 30 days. And then and if you include the lunch and dinner both, could be 15 days. But for paper plate, assuming that used only once, you need 30 paper plates. So the function, that's the reference flow for this paper plate. The flow will be 30 paper plates, 1 China plate. So that's what it says on this on the middle point, which says it will be different for each compared system. So that's what it is different. And then they are related to the functional unit by the key parameters for the optimization based on the product life, because the paper plate life was 1 meal serving. China plate, you can multiple meal serving. You can number of uses, how much times you can use it, and also like efficiency, amount of matter and energy used efficiency. So that's how you look at the reference flow. So these terms are very, very important, and it's very like, that's why if you make sure that you understand these very carefully, because these are very, like, these are kind of basics. You can say these are like alphabets of LCA exercise. Once you have a very clear understanding of what is the reference flow, what is a functional unit, what is function, what is the multifunctional, how to take care of the multifunctional parameters, what is the allocation rules, how we do that, and then the rest of the exercise is not that difficult, because you will be using a but again, when we use the software, many times I'm afraid to say that, because many times when I say, oh, you will be using the software, it will be fine. But don't rely on the software. You need to understand what the software is doing, because if you don't understand what the software is doing, you will make mistake. And then many times a student shows up in my office saying that this is what I got from the software. My answer to them that software is not getting a master's degree or a PhD degree. You are getting the PhD or master's degree. So you need to understand and convince me that what is going on. Software may make mistakes. So you as a human, like a researcher, you need to be convinced that software is giving you the correct numbers. So that's, I hope the reference flow is clear. So these are some of this very basic stuff in terms of function, functional unit, goal, scope. Now we will start looking at the unit processes. Unit processes, data and LCI database, which is next step on that. And again, we are still continuing that ISO methodology. These are again things are coming from the ISO standard. So some of these are it's kind of mixture of my explanation of the ISO standard, and I do have some of copy and paste from ISO standard as well. So in terms of the unit process, excuse me, unit process is a subdivision of the product system assuring a unit or a group of activity or operation. Now, if you look at the box at the bottom, so you have say there are two unit process 1 and unit process 2. Now for each of this unit process, we have this elementary flow coming into the system. And the elementary flow is your input going into the system. Now from the unit process 1, there could be some intermediate flow which will link unit process 1 and unit process 2, and there will be elementary flows which is coming out from unit process 1. Similarly, there could be elementary flow, same arrows could be down as well. We may have an input to the unit process 2 and things going out of the unit process 2 as well. So here, if you look at one unit process, it's the subdivision of the product system. So in a product system, there will be multiple unit processes going on. So those of you who are chemical engineers, you do this for PFDs, process flow diagram. You make those process flow diagram. I was working in a consulting company. You may be familiar, like you guys may have heard the name Engineers India Limited, EIL. And there we were doing a lot of work for petrochemicals, refineries, and offshore oil platforms. So although I was a civil engineer working as a civil/environmental engineer there, but many times we have to understand this PFDs. So because that's PFD was kind of the backbone. The first thing that for our any project will be this PFDs, process flow diagram. And based on the process flow diagram, all the services and all the other stuff will come. So civil engineer, mechanical engineer, all these engineers have to kind of rely on our chemical friends from the department, from the company, who will make the process flow diagram and share with us, and then we'll start working on our part of that. So that's the process. So there will be a lot of unit process. So it's if you think about a refinery, I just gave you talked about refinery. So think about a refinery. If you have even if you're driven by a refinery, or you have gone on a train where you see a refinery, or for that matter even a power plant, coal-based thermal power plant, you see there are a lot of things in there. There are a lot of cylindrical stuff, a lot of pipes going around. A chimney is most visible. You see chimney things coming out. And if you walk into a plant, those of you who have lived in a plant kind of environment, if your parents were working in the plant, or if you are right now in a plant system, as you walk around a plant, there are several things going on. Many times you don't really know what's going on in there, but each of them are having some unit process going on. So here, for each of those unit process, as minutely as we can, if we can get data, that's better it is. So it's a subdivision of the product system, where we have a unique or a group of activity or operations going on. So we have two types of flow, input and output. So if you look at any of these process system, there will be things going into the system, and there will be things coming out of the system. And the things coming out of the system could be part of the product, which will go into the next unit, which becomes an input to the unit process 2, or it could be some emissions going out into the atmosphere, or some liquid coming off, or the solid waste being produced. So those things are there as well. So there are two types of flows, input and output. Input is we have the intermediary or economic flow, which links us to unit process. That's the intermediary flow. The output from one unit process going to the input to the second. So that's called intermediary flow or economic flow. The second one is the elementary flow, which links the unit process with the environment. So it's the environmental intervention. Things going, it's like an independent. So things going into this unit process and things coming out of that unit process. So it has not linked to the other units which is associated with that. So those are, that's kind of just an introduction to the unit process, and we'll continue this unit process discussion in our next module, because it's one of the very important concept. So if you think about in this particular module, we kind of started again with the goal for the ISO methodology. We looked at the functional unit, goal, how you decide what goal it should be, what should be the audience, and based on the audience, how will you kind of refine your goal and scope and all that. So there is a lot of thought process goes in there, functional unit, multifunctional parameters. So again, and I'm giving you a lot of examples from that bulb problem that we did, because the bulb problem we spent quite a bit of time. So try to understand these stuff. These are again very, very basic stuff for this for a good LCA, and we'll continue this discussion in our next module as well. So thank you.